Today is day 2 of our final review. So once again, we are doing 16 through 30 for day 2. I will do one problem and you will have 2 from each type of section to do alone. So in day 1, we stopped right before getting to exponential form. So this section says write each expression in exponential form, and the one beneath it says write each expression in radical form. So I'm going to write the rules for this, and these can be used vice versa. So I could go from radical to exponential or exponential to radical using these rules. So if we have, so if we have the nth root of x to the m, or you could also see it the nth root of x all to the m. We rewrite these two things in radical form, these two things that are in radical form as x to the m over n. So these are radical form, and this one is exponential. So using these rules, we're going to do number 16. So 16 looks like my second form, which means here is n, here is m. So this would be 4v, stays together, all to the m, which is 4 over n, which is 3. So 4v to the 4/3. Okay. And I can go from radical to exponential and back to exponential to radical, right? Remember that all of this is from previous 6 weeks. It's not just what we've been recently working on. It's from the first semester, a little bit of the first semester, start of our second semester, a lot of the polynomial stuff, converting rational and radical back and forth. So let's go to the next section. So this says solve each equation. Remember to check for extraneous solutions. Extraneous solution just means if we get that type of solution and plug it back in and it doesn't work, it's a solution that we can't use. So this is solving radical equations. So the first thing I'm going to do is isolate the radical. Remember, I am a radical if I have this shape, my radicand. So we're doing number 19. So step 1, I'm going to divide both sides by 8. 0 divided by 8 is still 0. So now we have 0 equals the square root of x plus 9. So in order to get rid of a square root, we do the opposite, which means we are going to square both sides. If it were a cube root, I would cube both sides. A fourth root, I would raise it to the 4th power. So the opposite of what I'm doing. Square root and square will cancel out. 0 squared is 0. 0 equals x plus 9, and then to get x by itself, we would subtract 9 from both sides of the equation. So this tells us x equals negative 9. It says to check for extraneous solutions, so even though I got an answer, I do need to go ahead and make sure it works. I'm going to plug it back in. 0 equals 8 times the square root of negative 9 plus 9. Well, negative 9 plus 9 is 0, so this is 0 equals 8 times the square root of 0. Square root of 0 is 0, so this is 8 times 0, which is 0. This means our answer is x equals negative 9. So step 1, isolate the radical. Yes, you can have a radical on both sides of the equation. Just make sure one of the radicals has been isolated. So from these two sections, you have 20 and 21, 17 and 18 to complete. Let's go to the next section. So this is back to our logs, which you guys were great with. So we were using first first, last, middle. So that when I go into exponential, I am first, middle, last. So over here I have log base 14 of n equals m, so I have first, last, middle, and when I rewrite it, we want first, middle, last. So 14 to the m equals n. And I can go back and forth between those two forms, so I could go from log to exponential and exponential back to log. So next section for logs is expanding and condensing. I'm going to write all of the log properties down again so that you do have them. Let's try it again. So the first one that we have is product. Product says if we have log base b of m times n, we can split it up with addition and get log base b of m plus log base b of n. The second property is quotient. Quotient is division. Log base b of m divided by n, and we can split this with subtraction. So log base b of m minus log base b of n. And then the last one that we have is our power rule. This is for exponents. So if we have log base b of m to the n, our exponent would slide to the front, and now we have n times log base b of n. So we're going to use these rules in order to solve number 25. 25 wants us to expand, so I'm going from my multiplication to addition, or I'm going from a power rule to a number in the front, so a coefficient, or I'm going from division to subtraction. So first thing I can see is I have this exponent out here. So power rule says that slides to the front. So 3 times log base 3 of x to the 5th times y. The next thing that we can see is multiplication. So with multiplication, that turns into addition. So 3 log base 3 of x to the 5th plus, and this 3 is going to both things. Originally it was 3 times log base 3 of my two things being multiplied, so I give it to both of the additions. So plus 3 log base 3 of y. And then lastly, this exponent will head to the front and we multiply them. So 3 times 5 is 15. So our final answer will say 15 times log base 3 of x plus 3 times log base 3 of y. And then we have one more section. So before we get to that section, keep in mind when it comes to log properties that this side, which has multiplication, division, and exponents, is for condensing. And if we want to expand, we are adding, subtracting, or we are coefficients. So last section. Word problems. It says write an equation that models each situation. Use your equation to answer the question. 28 says Michael deposited $2,000 into an account that pays 8.5% interest compounded quarterly. How long will he need to leave his investment in the account before reaching a balance of $15,000? So this is compound interest. And the formula for compound interest is A of t equals P times 1 plus R over N, all to the N times T, where A of T, or A, would be the final amount, P is the principal or initial, T is our time, N is the number of times compounded per year, so we'll say number compounded per year, and R is our rate. Let's go back to the word problem. It says Michael deposited 2,000, so 2,000 would be our P, our initial. It says the interest rate is 8.5%. Well, our rate must be a decimal, so I'm going to move the decimal place over twice. It also says it's compounded quarterly. We'll think of quarters and a dollar. There's 4, so this is 4 times a year. And it says that the final balance should be 15,000, so this would be our A. So using this information, I'm going to go ahead and plug it into my formula. So I know what A is. It should be 15,000 at the end. It equals our P, which is 2,000, times 1 plus our rate of 0.085 over N, which is 4, all raised to the 4 times T. So we're trying to get T by itself, so my first step is to divide both sides by 2,000. So when it comes to zeros, when dividing, you can cross out the amount of zeros that they have in common. So this says 15 over 2, which is 7.5, equals, I'm going to go ahead and plug this right here into my calculator in order to get just one number. So I'll say 1 plus 0.085 divided by 4. And this is 1.02125. And it's still raised to the 4 times T. The last thing we worked on was exponentials. So when my variable is in the exponent, I do need to convert it. This is an exponential, so the opposite of exponential, its inverse, is a log. So here's my first, middle, last if I am in exponential form. So this becomes log base 1.02125 of 7.5 equals 4 times T. And then to get T by itself, we divide both sides by 4. So we get log base 1.02125 of 7.5, all divided by 4 equals T. And your calculators are pretty fancy. They will allow you to change the actual base. So if we type that into our calculator exactly as is, we get that T is equal to 23.96 years. So that's how long it would take before Michael's initial deposit of 2,000 reaches 15,000. For 29 and 30, I am going to go ahead and give you the equations. So 29, you are either using decay or growth. It is up to you to decide which one's being used where. So decay is A equals P times 1 minus R to the T, and growth is A equals P times 1 plus R to the T, where P is still principal, A is still final, R is still rate, and T is still time. So you have the remaining 10 from day 2 to complete. And then I will see you in tomorrow's video, day 3, for the last part of our review before finals get here. So good luck.